the average end user can say, oh, this sound is bad, or this sound is good, but they lack the skill to say, it's bad because of this and this, or it's good because of this or this, or it's good in that or this. So, hello, I'm Florian Heike, CEO of Celinius Company Limited, living in Taiwan for 25 years, and we are supporting European and Asian companies in their power electronics and special acoustics needs. We are looking forward to meet interesting people that are in this industry to make the world a little bit of a better place.
Hey, Florian. So we just had a conversation about power electronics, and I want to move the topic now to special acoustics. As I know, you have certain projects, you've had certain long-term clients in the special acoustics industry. Can you share what are acoustics and what are so-called special acoustics?
Okay, so I think humans communicate by voice, also by acts, but mostly by voice. That means somebody speaks, bringing the air into a movement, and then the ear of the other person is picking up the sound. So we have to come back down really to the basics, that our human ear is designed to receive acoustic signals for a frequency of about 25 hertz, the very low noise of the bass noise that you have in the dance club, all the way to about 20,000 hertz, which is a very high pitch noise. That's our human ear. Now, when we talk about the acoustics, acoustics has been used for thousands of years, usually by mechanical musical instruments, guitars, pianos, drums. We use acoustic signals to make our life more enjoyable, to have music, right? And now, for about 100 years, we use speakers which are powered by electricity to convey a message. Yeah, and I think we listen to our TV, we listen to our speaker, we listen to the radio. I mean, there's a lot of cultural effects about giving an acoustic message over a long distance. Now, when it comes to special acoustics, what you mentioned, I define special acoustics anywhere outside of your home. Because in your home, you have a space, maybe 5-6 meters to your next wall, and you use a home speaker on your TV or a bar or stereo or 5.1 system, whatever, to create an atmosphere in your home that makes you comfortable. However, when you're in a classroom or in a university classroom or in a conference room, you have a different setup. And you also have different targets than what you do at home. So we support companies that are engaged in places of worship, but also in public address situations where the idea to give a clear message to the listener prevails over giving a good feeling of a music. So that's already a difference. Yeah, if you go to the last disco pub and you listen to the boom 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 music, the speech you don't really hear the song so well.
Right.
Because you go there to experience the vibration, the power, the energy of the music. So this system that you have, let's say, in a disco pub has a very different target than if you're in a university classroom where you want to understand the word and the clarity of the professor that is communicating the wisdom of the past across to the students. So when it comes to special acoustics, again, understand where and what do you want to do. And that's where we support our customers.
Okay, interesting. So I'm curious, what are the parameters that you need to play around with when you have, let's say, one customer who's a nightclub and another customer who's a university or a church?
Yeah.
What are the parameters in the construction or the manufacturing side that determine different outputs?
Okay. So another thing, the acoustic output, I think everybody understands we have a microphone, so to collect the signal. Then we have a amplifier to amplify the signal, and we have speakers that give the acoustic wave out into the audience. But then there's one more thing. It's the building. The building has a major effect on whether the signal comes out. I think you may have experienced this if you go to railway stations, that you hear a lot of overlapping noise.
Yep.
And the acoustic wave is not just the one coming out of a speaker, it also reflects on plain walls. So since we both are in Taiwan, we know that in many restaurants, it is very, very noisy. And one reason why it's very noisy is because they have walls without any noise absorbing material. So the wave bounces against the wall, comes back to you, and you have the feeling like you're eating in a very noisy place. So the architecture of the place where you use the sound is extremely important for the overall experience. So a restaurant, it might be okay. If you're in a Yum Cha Hong Kongese restaurants, that's okay. When you're in a university classroom, that's not okay.
Right.
So, and our customers are engaged in designing the sound experience inside larger rooms. So it's a comprehensive approach. So, and it depends on whether you're targeting, like say, in a disco pub, you're targeting the experience, the feeling of the people that go there. In a university classroom, you clarify the understandability. In a church, you tend to have more older people. Older people tend to have a poorer ears. And you also have to support audio ad systems. So you want to make sure that the people can understand it, even in this acoustically not easy environment. And we're helping our customers to make products, or we're making products for them that are dedicated to be useful in such environments. And then our customers plan the acoustics by equalizers, by taking out specific frequencies which tend to resonate in the room, by putting in delay zones so that the signal that are emitted from speakers which are further away from the front will be delayed compared to the earlier speakers, so that when the signal from the front and from the back speakers arrive at the listener, they arrive about at the same time to avoid that overlapping effect. So yeah, it is sophisticated planning, and the average end user can say, oh, this sound is bad, or this sound is good. But they lack the skill to say, it's bad because of this and this, or it's good because of this or this, or it's good in that or this. So, and those companies that are in this industry, they are very specialized companies, but they are enjoying a continuous demand. And when they figure out that there is some gaps they are inadequately able to fulfill, then they could come to us and we would help them, provided that it's not just one or two speakers, because the quantity would be too low.
Right. Yeah, because I know for a fact there's thousands of audio or high-end audio companies, high-end speaker companies, making speakers for every single purpose. And I think we did chat about this before, but I'm not sure if any of these companies are taking into consideration what the room looks like or what the actual purpose of the speakers is, because I think what you do is you take the customization to a whole other level, right?
Well, you cannot do it all the way to the end. So it's always an interaction between the installer and the product. All right. So it's not just one product will fit perfectly in that one application if it's not installed or configured properly. So it needs skill on the product maker and it needs skill on the installer to install it. That's why this is a specialized equipment. And that's why there are also so many hundreds of brands. And it's not like on a cell phone where you have only 2 or 3 dominant brands. Because there is such a wide range of applications that where one product which may be good in one place, maybe not good in the other one, and depending on where the market goes. So, and it's very subjective. So what may sound good for one person may not be sounded so good for the other one. So it's a bit like when we go, again, coming to the wine, how many different wine brands you have in the supermarket shelf.
This is kind of a common theme with your business, I think, is that there's plenty of options for the end user, but it's almost like too many options.
Correct.
Yeah, and you help to kind of refine the solution.
Well, we're not selling directly, right?
Yeah.
So we are helping those system installers to make the product they need to meet their target.
Right.
And we are not competing in the consumer market like those boom boxes that you have now on every desk that you can carry around. And no, that's not our business.
Right.
Our business is those niche markets which tend to have some specialty. And as I say, we're here for the long run. We're not for the one time.
Beyond thicker materials, are there any techniques for controlling low frequency sound waves?
Well, we did have I'll call it not technological revolution about 10 years ago. When neodymium magnets became a material of choice for voice coils and speakers because they offer a much higher dynamic power. And you may remember when you read old magazines before we had the internet, there were people discussing about these big hi-fi boxes and wooden cabinets and people building them with these big magnets on those ones. But a big magnet to move, you need a lot of power. So it doesn't have this dynamic impulse, which is good for low frequency, but not necessarily for the clarity or the broader spectrum. So over the past years, the speakers tended to become smaller because by enjoying that additional efficiency from the neodymium magnets. But again, depending on how far do you want to go, what is the arrangement? So column speakers have a directional beam pattern that you can more adequately control. Therefore, it's more suitable for larger environments, whereas single point speakers will basically radiate out into the room. And you will always have an issue when you need more than one. Yeah, so it depends. That's as I say, it's not like a one-fits-all solution. You need to know what you're targeting.
Okay, so what are the most complex or difficult scenarios for special acoustics that you've encountered in your career?
Well, I would say one of the rather common challenges are that you never have the total freedom that you want. But you have to deal with existing architecture. You may have to deal with existing electrical wires, which may not be ideals, that are already installed. People cannot change them. So you have to see that you can make the most out of that. And in the PA, as a public address speaker systems, typical application are supermarkets or department stores where it is mandatory to have an alarm system to tell the people to run when there's a fire in the place, because this is part of the building code. So these technology typically employs a so-called 100 volt system. In the US, more 70 volt, but a 100 volt system in Europe, where the amplifier signal is first transformed to a higher voltage and a lower current, then transmitted through relatively thin wire, and then at the speaker level, it's transformed back to the original low voltage, higher current signal. The reason is because you don't want to spend thick wires over long distance part because it's copper, it costs money. So, and this technology is commonly also applied in larger spaces where the wires have been installed decades ago and nobody wants to open the walls. But when you want to get a good sound level over this kind of system, there are quite some challenges regarding the design of the transformers involved to get the whole frequency spectrum in a reasonable manner over. And you usually have trouble to get the low frequencies over. And if the transformer is not made so great, you lose things on the upper frequencies. You also choose the materials, the way it's wound, the way it's used, the way it's connected. These are all things. So as I say, it's not easy to get everything right, but it's easy to get one thing wrong.
Yeah. So definitely a lot of challenges. Now I can see why clients rely on you to solve these problems.